Hello, everyone. My name is Ryan, and thank you for the introduction. I'd like to give another thank you to all of the co-sponsors, co-authors, and sponsors that helped fund this project. This is not only my very first project of my PhD, but it's also my first oral presentation. I'm a little nervous, but I'm even more excited to share with you guys my research. All right, so previous research has found that the G allele is favorable in the WRS&P. This is one of the major findings found from the PRRS Host Genetics Consortium that Dr. Chris Tuggle mentioned early this morning in his presentation. We find that when comparing the marker genotypes, those with the favorable allele have lower PRRS viral load, and so AG is the red. They have lower PRRS viral load and higher weight gain, which is really good. Additionally, more past research has shown that there's a GBP-5 gene, guanylate binding protein 5, that holds a major QTL for host response to PRRS. And this, unfortunately, is not on commercial S&P panels, but the WRS&P is. And so, given that the GBP-5 is a major gene for host response to PRRS, and that WR can act as a marker for the GBP-5 gene effect, I'd like to introduce you guys to my 3 objectives. The first one is to determine whether genotype at the WRS&P is also associated with resilience to a polymicrobial natural disease challenge. The second objective is to determine or investigate the relationship of genotype at the WRS&P with genotype at its putative causative mutation in the GBP-5 gene. In previous research, we find that the genotype at GBP-5 was completely consistent with the genotype at WR. However, this was done with limited number of animals, so we kind of wanted to redo this experiment to see if anything's different. And last, my third objective is to compare the association of the WR versus GBP-5 S&P with host response to PRRS virus infection. In other words, we really wanted to see if GBP-5 had a stronger effect on host response than WR. So my first objective, again, is to determine whether or not WR-S&P is also associated with resilience to a polymicrobial natural disease challenge. This objective was addressed using data from the natural disease challenge model that I have a schematic up here for. So I'd like to thank Genome Alberta, Genome Canada, and Genome Prairie again for helping us out, and CDPQ for hosting all the facilities here. And so 7 batches, about 60 to 75 Yorkshire Landrace crosses were sent to came in using a continuous batch flow system. And at 21 days, these innate piglets would be sent to what is called a quarantine nursery. A week later, they had their blood drawn. 40 days later, they entered what is called a challenge nursery. And this challenge nursery is really important for my project. This challenge nursery has lots of pathogens, including bacteria and viruses, and it is because of this high disease pressure that we are able to collect phenotypes. The natural disease challenge really maximizes the expression of disease resilience phenotypes, including mortality, growth, feed intake, treatments, and more. And so the next slide shows some of the viruses and bacteria that were in this natural disease challenge. One of the big components of this disease challenge was the PRRS virus that was in here. And as you can see, there are many others. This natural disease challenge was established using cedar pigs that were brought in from other farms, and they were placed into this challenge facility and maintained using fence line contact as well as this continuous flow system. And so this slide is very simple. It shows the frequencies of the genotypes at the WR in the natural disease challenge. And as you can see, that there is a large amount of AAs. About 86% of them were AAs, and just measly 14% had a favorable G allele. And so this kind of goes into the next slide. This is the results of our natural disease challenge. And the main point that I want to show you guys is that those with the favorable allele tend to do better. And so you can see that we actually combine the AG and GGs together when comparing it with AA. And this was for two reasons. One, because we see that there's such a small frequency of GGs that we combined it with the AG. In addition, previous studies have found that the G allele is actually dominant. And so that gives us another reason to combine them. And let's see, having at least one G allele resulted in higher average daily gain in the challenge nursery, as well as fewer treatments. In fact, it's about those with the favorable G allele had about 27% fewer treatments than those without the favorable allele. And so that's pretty good. And so my next objective is to investigate the relationship of genotype at the WR/SNP with genotype at the putative causative mutation in the GBP-5 gene. We addressed this by genotyping pigs in 8 trials of the PHGC for the causative mutation in the GBP-5 gene. In previous studies, we found that the genotype at the GBP-5 was completely consistent with the genotype at WR. However, when redoing this experiment, we actually find that it's not. If you look at the diagonals here, we see that there's a very strong correlation between what we have at the GBP-5 and WR. But now that we have off diagonals, this tells us that, for example, not every GT is going to be an AG at the GBP-5 and WR respectively. And in fact, the correlation comes out to be 0.96, not complete as we previously thought. And so this brings me to my last objective. What is the association of WR versus GBP-5 SNP with host response to PRRS virus infection? We addressed this last objective by calculating the least square means by genotype at GBP-5 and WR for viral load and weight gain. We see that they're quite comparable. There's nothing too drastic between the two genotypes, but we really wanted to see which one had the stronger effect. Is it GBP-5 that has a stronger effect on host response, or is it WR? And these are the p-values that we obtained, and these p-values test whether or not there is a difference or whether there's not a difference between the effect of GBP-5 and WR and which one had the stronger effect on host response. So my conclusions, we find that the G allele at WR had higher average daily gain in the challenge nursery, lower treatments in the challenge nursery, and lower treatments across challenge nursery and the finisher pen. Second objective, we find that genotype at WR is not completely consistent with genotype at the GBP-5 SNP. Correlation is 0.96. Which is different from what we previously found. And based on these p-values, we are unable to detect differences between the association of WR versus GBP-5 with host response to PRRS. And with that, I'd like to thank everyone again, including all the sponsors and co-authors for my project.
We can take questions.
Correlation between WR and GBP-5. Did you notice, were there any differences by batch?
I did not calculate it by batch specifically, but I could look into that. That is something I can do.
That may be of interest.
Okay, yeah, definitely. Thank you.
So do you think there's any correlation between multi-diseases versus single diseases?
That's a really good point that you brought up, because this is a polymicrobial disease challenge, and so there's lots of viruses and viruses and bacteria that are participating in this challenge. So yeah, we have to discuss that for sure. Thank you.